Hi, I am Arib. You are watching my YouTube channel. Introduction to gas turbine power plants. The demand for gas power plants is increasing because of certain benefits. Natural gas is used as a fuel. Other fuels can be synthetic gas. Just like steam power plants in which operating fluid is water and steam mixture, in gas turbine power plants, air mixture is used as a derivative fluid. In a jet engine, one side has a turbine and one side has a compressor. The air is entered in the compressor, it mixes up with the fuel, it ignites, and then it ejects it from the turbine. The turbine converts the pressure and velocity into electrical power through the generator. A major problem in the operation of gas turbine power plants that when the fuel is being ejected, its temperature is 400 to 500 degrees Celsius, which can cause atmospheric pollution, and a lot of energy is wasted. Because of this wastage of energy, the efficiency of normal gas turbine power plants and open-cycle gas turbines is around 20 to 25%, which is way less than its potential. Even steam turbines have greater efficiency than this. The compressor and turbine are on the same shaft mostly. Compressor drives and compresses the air 15 to 30 times, and then the fuel is mixed, and when that mixture passes through the gas turbine at high pressure, the energy is converted. The energy required to drive the compressor is delivered to the compressor from the same shaft through the turbine, which means the major portion of the energy is utilized by the compressor to drive, and the rest of the energy is utilized in the turbine. The compressor has multiple stages: low-pressure compressor, intermediate pressure compressor, and high-pressure compressor. The compressor is the opposite of the gas turbine. The turbine uses kinetic energy and converts it into rotational kinetic energy. However, the compressor uses the rotational kinetic energy to convert it into potential energy of air and fuel mixture. Gas turbine. A gas turbine is used to convert the kinetic energy of hot gases into rotational energy, which in turns is used to drive the synchronous generator. It also has multiple stages: high pressure stage, intermediate pressure stage, and then low pressure stage. The combustion process takes place in the turbine, so, in order to save the blades from melting, the cooling process also occurs here. Most of the time, a cooling fluid is constantly passing through the blades. Compressor. It is mounted on the same shaft. It compresses the normal air and delivers it to the combustion chamber. It also has multiple stages: low pressure stage, intermediate pressure stage, and then high pressure stage to increase the efficiency. Combustion chamber. The compressed air is entered here and it mixes with the fuel. It is then ignited here, which causes an increase in temperature and pressure. The temperature can go as high as up to 1400 degrees Celsius. At this very high temperature, the nitrogen can combine with oxygen to produce nitrogen oxides, but this is controlled such that all the oxygen is utilized in the combustion process. Auxiliaries for the operation are gas turbine power plant, different starting devices, fuel system, oil system, lubrication pump, but they are not the parts of our focus. Thermodynamic cycle of a gas turbine. Gas turbines operate on Brayton cycle. 25% of energy production in the world is based on gas turbine power plants. This percentage will increase further when there is a decrease in energy production using fossil fuels. The efficiency of open cycles can be increased by up to 38%. Small-scale gas turbines can be used to obtain 35 to 45 megawatts of energy. Open-cycle gas turbine. If the exhaust is dispersed in the atmosphere, this is called the open-cycle gas turbine. the energy of exhaust cannot be recovered. 50 to 55% of energy is wasted in the exhaust. Combined cycle gas power plant. In a combined cycle, exhaust gases are used in the steam turbines and their energy is recovered and utilized. Larger gas turbines have less efficiency, but due to modern research, its efficiency is increased up to 38.7% and its unit size is also increased. Previously 50 megawatts of gas turbine units were used, but now up to 265 megawatts units can be used. The efficiency of the gas turbine plant depends on the inlet and outlet temperature of the turbine portion. The inlet temperature is around 1400 to 1600 degrees Celsius and the exhaust temperature is about 400 degrees Celsius. So the lower efficiency is due to this temperature difference. In future, if good quality material is used, the temperature of combustion chamber can be increased, which can cause our overall efficiency to increase. Energy cycle. Inlet energy is due to ambient temperature, so it is minimum. The compressor compresses the air 30 times, then it is mixed with fuel and burned, so the major portion of the energy is from the fuel mixture. Compressed air energy. Fuel energy is the inlet energy. It is converted into rotational energy. It is converted into electrical energy. Around 80% of energy is wasted in open cycle gas turbines, but it can be recovered if we use combined cycle gas turbines. Methods to increase efficiency of an open cycle gas turbine power plant. There are two techniques available to improve the efficiency of an open cycle gas turbine power plant. 1. Combined cycle power plant. 2. Integrated gasification gas turbine power plant. Combined cycle power plant. The exhaust waste is used in heat recovery steam generator. Mainly two turbines are used. One is gas turbine whose exhaust is utilized by the heat recovery steam generator and generate steam and run the steam turbine. So in one unit there are two turbines and two synchronous generators. Efficiency can be increased by 50 to 60%. Integrated gasification cycle power plant. When fuel is not available, other fuel is gasify. Boiler, gasifier, is used to gasify the low-quality coal, waste material or biomass by partial combustion. After it is gasified, the hot gases produced are CO, H to CO2 which are used. Choice of fuel in a gas turbine. Based on the characteristics of the fuel gas turbines are designed. Only then, the designers can guarantee the proper working of turbine. The design of combustion chamber is of prime importance for efficiency. Similarly, the temperature and pressure are also continuously monitored. Advantages of a gas turbine power plant. 1. Their popularity has risen over time, nearly 90% in USA. Now they are used as standard prime movers for many industrial applications. 2. Most efficient to convert fossil fuel to energy. 3. Turbines 35 to 265 megawatts output, 38% efficiency in power. 4. Smaller in size and no release of harmful gases. Disadvantages of a gas turbine power plant. 1. High rotor speeds. 2. Low life and efficiency. Enhancing efficiency. Combined cycle plants. The exhaust gases from the gas power plants have a very high temperature, so they can be used in boilers to heat water to form steam. This steam is then used to drive steam power plants, thus enhancing efficiency to 60%. Integrated gasification combined cycle plants. The coal extracted is combusted in modern gasifiers. This combustion produces a large amount of heat. This heat can be used to drive the steam turbines, as water will be converted into steam by this heat. The combustion processes also produce gases such as H2 and NOx. These gases are combustible and so are used for combustion in gas power plants. The exhaust gases out of gas power plants are again used to drive steam power plants. Thus, overall efficiency is increased up to 45%.